So this is the NF to Infra meeting on the 12th of December. So I basically updated, so this is continuing of a brainstorm. So I updated the slides a little bit based on, so I don't know whether any of you have given it some more thoughts or not, or not, right? Otherwise, I'll see. I took the opportunity of having a face-to-face time with John in KubeCon, and if nothing else, I can explain what we kind of came up to on how we can potentially solve this problem, right?
Yeah.
And so, yeah, maybe I'll do a small recap, right, of what we are trying to do, right? Do I need to put it in presentation mode or not, right?
I'm not seeing anything on the screen at the moment.
Wait, okay.
Yeah, it's not presented. Although I'm looking at the presentation directly right now anyway.
So I first have to share. Okay. Before you can do anything. So this, I didn't update any of these slides, so this is as is, right? So the focus of the topic is NF to infra. So how do we, let's say, deploy network functions? But it can be broader than network functions in my view. If you look to the approach that we took, I think we can use this also purely for software install or for many other things. But yeah, so in other words, you have a set of resources that you want to apply to a cluster. And yeah, so that could be multiple NFs and stuff like that. So basically, the problem that we have is how do we resolve all the dependencies to make that happen, if you will, right? So from versions and resources and stuff like that, right? So and so far, I think the first focus is to focus on a single cluster, right? And focus on the capabilities rather than the capacity, so the selection criteria and stuff like that, right? So this was a bit the framework that we had in mind, right? So we have requirements that we identify, which can be software and configuration. So, and there are things that you own and things that you're depending upon. So I hope with the example that we came up with, we can make this a bit clearer, right? And then, so this, you could say these are the dry requirements, which will be actuated onto the existing environment. And then these are basically our requirements that are specific towards that instance. And then we have someone who is basically validating and approving it, and then it gets instantiated, and the approval can potentially be various people that act upon that, right? So that's kind of a little bit the system from a high level that we were trying to put. So basically is the high level framework that we would like to achieve, right? So are there any questions so far on this? So if not, I can start with the slides. So I put together, I didn't have a lot of time yet, but I put together a little bit, but I'll explain. I even can do a small demo to make it a bit clearer, if that's okay. So if you look at the landscape, so what we did is we basically took a complete fresh look at this, right? And if you look at the landscape that we are talking about, then we can actually segment it in three or in four categories, if you will, right? And maybe it can be a bit more, but to make it clear is the following. So we have basically core, what we call core KRM resources and schemas. So this is actually all the core resources that Kubernetes comes with when you install a cluster. So like namespaces, config maps, secrets, pods, deployments, stateful sets and stuff like that. You don't have to worry about them. They are there, right? So every Kubernetes cluster you install, you get them, basically, right? Then what we also have is we have a set of extended KRM resources and schemas. So these are, I call them the CRDs. So these are and I call them KRM these days because when I were discussing yesterday with Tal, right? So some of the although we call them CRDs, they are not actually inside of the cluster, but they represent something that we might reference. So if you, for example, look at specialization in release that we did in release 1, there is a bunch of resources which are modeled as KRM, which are not really CRDs as such, because they are not even installed on a cluster, but we consume them to accomplish something, right? So for me, all of these fit into this bucket, right? And so these are basically extensions that we do on top of the core, resources, right?
Yeah. So if you were to look at something like CNI or Metal LB, are they in the first bullet category or the second bullet category?
So the core CNI is here, but there is no resource which basically says CNI, right? You don't have a CNI resource, but what you then have it, for example, if you have Calico, which comes with its own specific CRDs, right?
Yeah.
As well as Cilium, then they fall into this category in terms of the schemas that we rely upon. And I hope to make it a bit more clear when I explain, because so to give you an example of why I'm making this point is the following. So let's say, so you deploy a set of configuration that needs Cilium, right?
Okay.
That cannot be accomplished unless Cilium is there. You see what I mean?
Yeah.
So that's why this nomenclature or sometimes is important, and to be able to resolve the dependencies, if you will, right? So these things are there to resolve the dependencies.
I know my question was just the first part. It doesn't include say non-Nefio things that aren't standard Kubernetes. That's fine. Okay. And
yeah. So this is basically, if you install Kubernetes, you get these resources out of the box, basically.
Yeah. So it's your replica sets and all that.
Yes.
Everything.
Deployments, stateful sets, secrets. There is, so
Ingress,
CRDs.
blah, blah, blah.
Yeah, so Ingress CRDs is actually a resource, right? That Kubernetes gives you, right? So that these are, so I'm calling these as basically available by default in Kubernetes cluster, right? Now they depend on a release, basically, right? So it might be that depending on the releases of the Kubernetes, they might have. So there is still something that you need to know, right? But it's not. So the difference between this one is that here you need to basically install a CRD before you can actually consume it, right? And you need to have a piece of software that acts upon the CRDs before you can do something.
Yeah. So the first one you can assume that they're.
Yeah. Yes, correct. Yeah. That's the difference between the two. Yeah. Now then, we thought about the concept of what we call a provider, right? So a provider, and we can, we believe that we model them as packages. So they are, so basically what they are is, they are a set of resources, so KRM, right? That do something, okay? So for example, so it's not only the CRDs. So the provider is actually a collection of a bunch of KRM. So typically I think of them as, so they have a schema. So there will be CRDs most likely with them, right? Because otherwise this is the core. So you could think of the core Kubernetes as a core provider, right? So it's basically the APIs, so the schemas, plus also the software controllers that act upon these things. right? So that's what you can, what we call a provider. So this is something that achieves something. So you could, so I think of ports as a provider. So if you install ports, what you do is you install the CRDs that ports brings, you install the software, and you install a set of configuration artifacts that depend, so that typically, so today in ports, they are only depending on the core KRM resources. So they are depending on this, right? And so so that's kind of the artifacts, or the provider package of ports is actually a collection of these three things, right? So that's what we call a provider, right? And so those providers will be a unit that we basically leverage to resolve our dependencies eventually, right?
Wim, just a question. Yeah, is that unit concept is similar to the one defined in Silva, or?
This, I don't know what is defined in Silva, so I'm not sure whether it's unique.
Okay.
But so this concept is inspired actually by Terraform. This concept is inspired by Terraform because that's how they do the whole thing.
Yeah, but maybe I can, yes, I can try to find the right information, but because in Silva, they are also using this kind of unit concept. I'm not sure this is only assembly of KRM, but I can check. I will check.
Yeah.
It seems to be similar. So.
Okay. Yeah. And then, so then there is a fourth piece that you can have, which is purely config, right? So you could also have a unit, which I call modules. So you will see in a bit. So actually, I'm inspired by Terraform, by the way, for this. So a module is basically a config set of artifacts that consume providers, and then typically providers will consume core resources. So you already see that how you can build dependency trees with this, right? So that's kind of the let's say the resources that we would think about, if you will, right? So now, if you then to make it a bit, what are examples of these? So typically, so a provider, so I still call them packages, right? But they can be, I didn't make a distinction yet on how to do it yet, but so they could be identified as group version kinds, or as an OCI repo, or in Git, right? So this is how you identify them, right? And a provider typically comes with a schema, right? Which is actually the what that the provider actually supports. So if you come with ports, the APIs, the schemas that ports gives you are actually the identities that this provider, let's say, gives or brings to the cluster. And someone then can consume that to achieve what ports as a provider actually provides within the cluster, right? And so so besides the CRDs, it also gives you, or we should call them CRD/schemas, because in some cases they are not really, so they are not really CRDs that are, let's say, applied in the cluster. So they can just be a KRM schema, but we all use, so the format in which they are specified is similar to how a CRD is structured. It's actually a CRD based representation, right? But they might not be applied into a cluster, right? And then, so what you have typically besides that is you have a set of configuration. So you basically say, you have a deployment, for example, in Porsche, right? That basically installs the controllers that are acting upon these schemas, right? You might install config maps or secrets or stuff like that. So there's a bunch of configuration that you manage that is basically relevant to achieve that provider instance, right? So this is typically a set of configuration artifacts. So for me, the way to represent this, if you look to our example packages of ports, or even MetalLB as an example. So if you look at MetalLB as in our package, it's a provider that gives you load balancing, right, in a specific way. So this is what how we think about that. Right? Then there is a distinction between provider and a module, right? So it's a little bit, typically a module. What's the difference between a provider and a module? Here you don't actually see, let's say, I don't believe you see here really software that acts upon it, but this is a collection of configuration artifacts that can reference providers, but can also reference potentially modules, right? So here you basically build a module that represents a set of KRM, right? And this KRM is actually calling upon these providers, right? Which can be the core provider or not. But actually what you can also do, and that makes it interesting, I think, is that you can reference other modules. So think of this as, so remember that in specialization, for example, we have a function today that creates interfaces with IP addresses and network attachment definition, right? So you could think of this as a module that achieves the creation of an interface, right? So these are a set of artifacts together that don't really install new software and stuff like that, but they are referencing other, let's say, resources that achieve those type of things. So in other words, the reason to call them out is to be able to manage all this KRM, if you will, right? Because at the end of the day, what we have to do in NF2 Infra is basically, you have a bunch of KRM, and you want to apply that to the cluster in a way that you resolve those dependencies. So for example, if you're relying upon a piece of software that is not yet installed, you want to have a system that triggers the installation of the software before you can actually apply that module. So the reason to segment this into these units is to be able to manage that whole dependency tree, if you will. Does that make sense? Or
I'm a little bit hazy on the difference between the provider and the module. Is the module some sort of config?
So module is a config, correct? So it's a piece of configuration that you want to apply, but a configuration can also be depending on it cannot be just a single config. It can also be multiple configuration.
Yeah, so it's a kind of a setup for a particular domain situation that pulls from all the provider packages that's there.
See, let's take an example of a module, right? So let's say I have a module which is basically an interface, okay?
Yeah.
So to create an interface, I need an IP address, right? So this module, what this says is, okay, I'm the module that gives you, that is responsible for creating interfaces, okay?
Yeah.
So it has a schema of interface, if you will, right? So it owns that. Now, within this module, to basically create an interface, let's make it simple, I need an IP, right? So this module package defines a resource that says, for this interface, I need an IP. So this IP is another KRM that will be called upon based on parameters that are in the interface. And this IP is depending on a provider which provides IPs. So this basically calls upon this provider, which is an IP provider, right? So you already see, so in this module, which is responsible for interfaces, will say, for this interface, I need an IP. So there will be a KRM inside of that package, which says, I need an IP. And that IP will call the provider, and the provider will then, that's the,
okay.
The thing that basically is responsible for giving you these IPs.
So you define a resource in the module which says I want an IP. Okay, and then what resolves that, or what reconciles that?
So in other words, to give you actually, let me show you an example. Okay, it's probably easier. on how to do it. So I built a tool called Kform, right? So Kform is a tool that does this, by the way. Okay, so it's still because I started to I showed this to John when we were discussing. So to give you an example, and basically I modeled our specialization to a certain extent. So, but to make it simple is, so for example, let's talk interface, right? Because that's the one that we were discussing, right? So an interface, so what you see here is, so this is basically what I call a module, okay? And so this module has, for example, you see here, if you look at this, you will relate. So this is what we add in specialization, right? So basically in specialization, we say you can put into a package an interface that has these characteristics, right? So a module, you can provide the input. So this is the static input, right? But you can also define it dynamically. So through the package, so when you create a package with the injection, the idea is that you can actually inject this from, let's say, an upper resource, right? But this is kind of what this module basically provides. Okay. Now this basically this module, if you will, to achieve that this requirement, right? What you have to do is you have to get IP address, right? So what you do is you say, I have a resource, so, and depending on this input, it might be an IPv4 or an IPv6 or both, right? And there might also be a VLAN associated with it, right? So there is what you do in, so this module, you write, so basically this is so this is getting an IP for IPv4. This is getting an IP for IPv6. This is getting a VLAN, okay?
Yeah.
So based on the input that you get from in the module, you call upon these resources with so this is basically the syntax that you see here is exactly the same. No, it's 95% the same as Terraform. So you have also count, and so you can have conditionals and you can have loops, if you will, right? But you can also see that you can do value or variable substitution depending on whether the input that you have here is actually a loopback or network. So you can build some basic logic into this syntax, right? To be able to achieve something depending on the input, right? So you can do like what I call variable substitution, and you have some basic logic to express yourself. But if you look at this syntax, it's 95% same as Terraform.
But yes, maybe I just have a question, because here you are defining not only requirement for infrastructure in terms of Kubernetes resource on the maybe host capability, but also on networking between your clusters, or do I miss something?
Yeah. So what we are trying to, so if you go back to what we are trying to do in NF2 infra, right? As a thing, at the end of the day, so the idea was always, okay, I have a piece of software or I have a piece of configuration that I want to accomplish, resolve it for me, right? You don't want any human, you can still have humans involved to do the approval, but you want to have a system that resolves automatically all the dependencies that are needed to be able to accomplish that, right? Okay. So you can basically start from an empty cluster. You basically say, so the idea is you say, I want to deploy a network function, right? And the system will resolve everything to accomplish that. That's kind of the ultimate dream. Okay.
Okay.
Right. So
okay.
What I'm trying to show you is a unit to accomplish that. I'm not showing you the full system, but what you see is that by segmenting the system into these let's say, manageable items, sorry, it makes it easier to, let me drink a little bit. Sorry about it. My voice is a bit dry. So to be able to manage, because what you actually have to do is you manage the dependency tree, if you will, right? That I model, with this implementation, I model as a DAG, right? So under the hood, what you will see, I'll show you a demo in a bit. I model a DAG, and the DAG actually is the thing that basically says, okay, I'm dependent, this is dependent on this is dependent on this is dependent on this is dependent on this, and that will execute it to be able to accomplish your NF that will be deployed at the end of the day, right? If you see that you have a dependency that you cannot resolve, it will, at some point, it will block at that point, but it will also say, hey, I don't have a package to do this, so please provide it to me, right? Okay. Does it make sense? So that's kind of the ultimate dream, right? But in order to accomplish that, we introduce a concept, what I call modules and providers and stuff like that, right? And if you look at Terraform, so I was inspired by Terraform because they have exactly modules and providers. That's it. Okay? And then within a module and a provider, you can have other dependencies that basically resolve that. Okay? So what I was showing here is actually, so a module and a provider, they can also have some business logic to achieve this thing. And why is this business logic there? Is because so you could say, I have a dry package, right? But for example, if you instantiate it on cluster 1, the IP addresses that you want might be different than when you instantiate on cluster 2, right? So what the business logic is giving you that variability to make it flexible, to have a single package that, depending on where you deploy, will resolve it with the right, let's say, parameters. You see? Okay. Okay. So, and that's what this business logic at the end of the day does, right? So what this business logic does, so for example, what you saw in the input, which I did not explain, is you, for example, can have a cluster name as input. So it's another level of variability that you can add to the system. And depending on this cluster, that could, so when we look at package variant set, so the idea is that they set them, right? And that is then an input parameter that we use. For example, you see here that input context cluster name is used to supply it to the IPAM, right? So the IP address system will use that input to make it context aware. You see?
So is that, so the module is collecting, but also configuring, or configuring the packages for the particular setup that it's targeted at.
See, just to let me first go through there, and then we'll make an example, and I'll put. Let me first go through this, Leah, and then hopefully maybe it's not 100% clear, right? But so in other words, this is a dry. What I show you is a dry module package. Okay, so it has some business logic, and then it basically spits out an output, right, based on the information that it got, right? What you also see with this approach, by the way, so let's say a byproduct of this is for special. So if you apply, you will show this actually in specialization. We don't need to write any code anymore with this approach. So all the functions. So we still have the choreography and stuff like that, but the functions as such, they all disappear if we go down this approach, right? So now let's say, okay, I want to install this guy, right? So I want to, someone says, I want this to happen. By the way, what I did not explain is you see here that there is a difference in, and this is just a syntax that Terraform uses. So I basically use that because I believe that leveraging a syntax that is already known is probably way more easier to grasp than nothing. But what you see here is that there is a concept of a resource. here, right? So a resource is actually linked to a provider. And the way this is happening here is, you see here, resource backend is linked to a provider that is available at this location. And you can specify the version and stuff like that that you want, right? So, but at the end of the day, so this resource backend, if you see back into here, you see that this is calling a provider with this specific schema. And the schema is actually defined here, right?
Okay.
So you see that actually there is, so this system itself is actually calling upon a provider model already, that basically, which is the resource backend in this case, that basically provides IP addresses. So if this is not installed, I will not be able to accomplish that, right? So now the syntax, so for example, let's say I apply, wait, so it's interface, right? So let's say I'm going to apply this package, this module onto the system, for example, right? Okay, so what this thing does, right? It actually resolves, so it goes through this file, it parses the file, and it maps dependencies, right? So what you will see is here, I cannot parse, yeah, the error is a bit verbose, right? But see, the following providers are not up to date. So I'm having a dependency on a provider that is not installed. Okay. So, and what is the provider? So if I do init, so at the moment, so basically this is exactly how Terraform works. So it's init and apply, right? So, but we have to map, if we go to this approach, we have to map it to the system. So if I do init, it actually installs the provider, by the way. So you see here that now this provider of that I was referencing, so the resource backend is now installed, okay? So now when this provider is available, right? So you see already the dependency tree. Now I can apply the cluster, right? And so if this instantiates, right? So what you'll see is that now it actually gives me an IP with a bunch of IP addresses, right? So it gives me interface, the prefix. So it's basically, this is what we did in specialization in R1, right? So you actually provide the IP address that needs to be available. So this is actually the resource. So now, so in the case of NF deployment, what we saw is that we were depending on multiple providers. So I also modeled here NF deploy, right? So if you look here, so this is deploying a network function, right? So here I'm relying upon a DNN module that provides me DNN capabilities. I rely upon interfaces, and I rely upon network attachment definitions, right? So in other words, what you can now do is you can build what I call this Lego system that consists of modules and providers. And when you want to establish something, you call upon, let's say in this case, we started with NF to infra. You basically say, for this network function, this is, so I start with this package, right? And if you look to the way this package is constituted, it's the same. So you have an NF deployment, which is your UPF, right? You basically say, you could also add interfaces to this if you want, right? Or not, right? So this is basically whether you do that or not. So the interface can also be injected dynamically. You can provide some context. So this is kind of how that configuration, this module, so what that, it's basically the input schema, if you will, from this module, which is all KRM modeled, right? And then what you say in order to accomplish this, so here you now see a little bit of a different syntax. You say, okay, first of all, I need to get a network instance or a set of network instances that I'm specifying in my input, right? So that's one thing that I need. But I also want to have a module of interfaces and DNNs, right? So this will call upon the module that provides the interface and provides a DNN in the same way as you call upon providers. And these could call upon other modules or providers, and that system will build you the full tree, right? And then what you actually see is that you need something that sees, okay, is this installed? Okay, is it okay? Then you go to the next step and stuff like that. So you basically build a pipeline, or actually this dynamic dependency tree that executes all this KRM in sequence based on the input that you got, right? And so we believe by modeling the system, or by segmenting the system in this module and provider concept, you're actually able to do that fairly easily.
So can the main, so would the main be the same from if I'm installed to install Vim, and with different inputs depending on what you're doing, or would it be different? But
so the way let me maybe draw it, that might make it hopefully simplify it, right? So the way what I'm explaining, what I'm trying to explain is this, okay? Or what I'm trying to tell you is this. Wait, so that's not the right thing that I want. So let's say, so what we are saying is basically this. So we have a system. So you basically have a set of providers, provider, right? And you have a set of modules, right? That's, are you familiar with Terraform or not?
Yeah, I'm not familiar with Terraform, no.
Okay, so let's say you have providers, right? So think of a provider. Let's build an example. What is a provider? Porch is a provider, right?
Yeah.
Our resource backend is a provider, right? So let's call it PE to make it simple. But for example, another provider is our workload, like FreeFileDC, right?
Okay.
Or OAI packages, right? So all of these are providers of some sort, right?
Okay.
So a provider, each of these things, they model what I call, so they have a schema, right? And a schema is nothing else than a KRM-based schema, right? So this basically specify what they do, right?
Yeah, no,
and
that's fine. Get that.
Yeah. Okay. And then what you have, so the second thing that you have is basically a module actually also has a schema, right?
Okay.
Like the input that you have, like our interface or NF deployment. So these are the NF deployment CRDs, right? And so now what you do when you need to accomplish something, right? So that's kind of resources that you have available somewhere. And let's say we add those into Porch, right? So Porch is actually our system that provides them, or this can also be an OCI registry or basically Git or something like that, right? So this is something that when you, if you are an operator, let's say Eric is here in Orange, he basically says for Orange, these are all my providers that I pick, and these are all my modules that I pick, right? Okay. And some of these modules will be, and some of these modules and provider will be open source and available openly, right? And a set of these things also, the people in Orange or certain system integrators can assemble some of these things by themselves, right? So they can build their own providers and their own modules. Mm-hmm. So we don't want to constrain that. But let's say for a given, let's say, service provider who wants to use this, they have access to a set of providers and modules, and whether they are all public or not, I don't care at the end of the day, right? Yeah. So now, if you see, let's say our goal is, I want to deploy a network function, right? Okay, so now this is a specific implementation. And so what you do is you basically, to build a network function, I probably have a module that does that, right? So I basically instantiate the network, the NF, so the network function module that you got here, right? You instantiate, but you have specific parameters that constitute your environment, right? Okay. So for example, you say this is on this cluster. Let's make it easy, right? So cluster A, okay? And you will see that our package variant and package variant set is going to play an important role here, because that's basically reused as is, right? But you basically say, I want this module, right, which is network function, and I want to deploy it on network on cluster A, right? So, and that's the specific input that you put to this this module. Okay.
Okay, so you configure that module in a certain way for that cluster.
Yeah. Now this module that you built, right? So that is here, actually is going to be dependent on another module, and the other module is interface, for example, right? And the other, so then there is another module, right? That is
DNN.
Yeah, DNN and stuff like that, right? So you see, and then these guys are depending on a provider. So you basically see the tree already, right? Right?
Yeah,
so this is depending on a provider for the backend, right? So what the system actually does under the hood is building this whole tree and resolves the tree, and then there is an execution engine that acts upon this tree, if you will, and that's going to say, okay, I first need to do this before I can do that, and then do this, right?
And is the left hand side is the dry, and the right hand side is the wet?
Yes, correct. So yeah.
Okay.
And so what the system will do is basically it will pick the right things, and then within, so there is basically different dimensions. So there is a system that basically picks these modules, right? Put the right context inside to be able to execute them, right? And then once executed, they will say, okay, now I can execute this, and then I do this in parallel, right? Because there is no dependency between these two, so I can run these in parallel. And then at the end of the day, I can execute this, and I'm happy, right? Hopefully everything works. So that's kind of...
We use the package variant set package variant mechanism to do the hydration.
Well, the hydration is based on the system that I show here. But for example, if you need this module to be deployed on 10 clusters, you will have 10 of these. So you'll have 10 instances. So you'll have basically 10 instances of these with their own specifics on where they are deployed. So you will have cluster A, B, C, D, and E, and so on. Cluster 1 till 10, basically.
Okay.
Right. And so you have an instance of this 10 times, basically.
Okay.
Does that make sense?
Yeah, I conceptually, I think I'm getting there now.
Yeah. Anyone else having a question or a comment or a remark? Or does this make sense or not? Or
yeah, it's better with example, yes, to understand. Yeah.
It's a bit abstract, but so one nice byproduct of this, by the way, is I can actually, so we can do specialization without writing any code with this. I mean, you of course have to implement the system to be able to run this, right? So that's you have to deploy, but this whole system can, so basically, if you look at what I just showed you here, this is actually what our specialization functions do today. And so I was able to accomplish this by actually my code. This is actually the equivalent code that I wrote instead of the functions. So what am I doing into this code is basically checking, okay, do I need to give you an IP address? So for example, if I change the input here, and I say, because right now the output is V4 only, right? So if I would change the input and I say I want dual stack, okay, let's change the input. Okay, I run it again. Okay. Yeah, so there is still a bug that I need to fix, but so I will, okay, once again. So there is one dependency tree that, okay, so when you do a demo, it always fails. Okay, so this works. So what you see now, I get V4 and V6. So you see, so without any, so this is just changing the input basically, right? By changing the input, if your business logic takes care of it, so what is the business logic doing? It actually checks if network instance default. So for example, if I would change this network instance to default, so this is now specific to our environment, right? So if you, so this, so in release 1, this means the IPAM shouldn't bother. So this is actually the default CNI, so we shouldn't do anything, right? So if you run this again, right, you will see now that I don't get any IP, right? So the business logic that sits behind here is actually, yeah, I'll change it again, right? So the business logic that sits behind here is actually all here. So what you say is that if the network instance name is default, right? Don't do, so I don't need, if it's not default, I need to run this. If not, I run it, right? So that's kind of what you do, okay? And if it's only IPv4 only, or if it's dual stack, then I run it, right? So that's kind of, so this is basically Terraform syntax. So Terraform runs exactly the same. And so what you do is that depending on this, so you can basically see you have like variability and stuff like that. So it's still a bit of code, if you will, right? But it's not real Go code, right? So it's kind of it's a DS. So basically it's Terraform language. The thing that resolves these variable substitution is actually what is happening is using cell functions, right? So that's what Google came up with. So that's the same, let's say, system that is used in policy and validation and stuff like that. So under the hood, there is a cell function that executes. That's also the one that we use in PVS. So package variant set. So it's a fast way to execute something, right? And so each of these are actually variables that you give into it, and then it will basically give you a result, and this whole thing executes based on those information, right? But so you see that each of these variables that you put here are dynamic, right? So if you have a dollar, so there is, yeah, so syntax wise, we can maybe avoid the dollar sign, but at the moment the dollar sign is what I use to resolve it. But so this basically resolves this cluster name based on the input of the cluster name that you provided here. So if you give this H1 or H2 or H3, it will become H1 and H2 and H3, right? So you see, so that's the business logic that sits underneath here. So, which in my view means also, or I'm hoping that as long as you know Terraform and stuff like that, building this will be very easy to do, right?
Okay.
And so that's the business logic that sits behind this module, if you will. But in a provider, you can also have such a business logic, right? So for example, so we have Gitty, right? So Gitty as a package is, I call it a provider, right? A provider that basically provides Git services. Now, you know, to access that repo, we need an IP address for Metal LB, right? So when we deploy, so that's the thing that you had an issue with, I think, Liam, I saw on the Slack, right? But
yeah.
So you need that IP. So in other words, within this provider package, you could also say, I need an IP address. When I install it on cluster A, I need a different IP than when I install it on cluster B. And so a provider can also have a bit of business logic, but probably way less than a module, right? But it can also have this business logic a little bit. So the syntax to do so, it will be the same as what I showed you before. But as a result, what you now get is that this provider will not be able to be installed unless an IP address is resolved. You see?
Okay.
So in other words, so the system now becomes recursively depending, but because of the fact that we have core resources that eventually are the ones that we rely upon, right? Because it all comes down to that, right? You basically resolve to the root, if you will. So the core is actually the root of the tree. So if you have a dependency on this, you actually are at the root of the dependency tree. And as a result, you basically, that's the thing that we always need to be able to accomplish this, right? But so we always resolve to the root, and as a result, then that's how this system works. But basically installing new software or configuring something new, right? I think with this system, we have a way to basically resolve that and get, I think, to the dream, Eric, right? To say, okay, I want to deploy a network function. I have a dry Kubernetes cluster, and it basically is going to automatically install the whole freaking thing.
Yeah. Okay.
Of course, a lot still to be done, but yeah, conceptually, yeah. So that's kind of how we were thinking.
Yeah. What sort of engine are you using to do the resolution of the hierarchy?
So this is a regular DAG, right? So it's a directed acyclic graph, right? That is being built upon rendering this the system. Yeah. That code is less than 100 lines.
Okay.
And then there's an execution engine that basically runs the DAG and installs the DAG and basically executes the DAG. But here we need the DAG at various. So every provider is a DAG on itself, right? So this is a DAG, this is a DAG, this is a DAG, and then you have a DAG across them, right?
Okay.
So there is, but the system is hierarchical, right? So, but it's the same DAG, right? So there's no new DAG. It's just the way you build it is using these modules and providers rather than the individual resources. So you basically build a hierarchy of things. So that's why calling out providers and module is important, because this can have a dependency on a provider. So I'm not going to, in this module, figure out all the dependencies that he needs. I'm just going to call upon, hey, I need a provider, and then the internal dependencies that he has to accomplish himself, he will resolve, right? But so I'm only depending on, hey, are you ready or not, right? So I'm depending on the provider telling me, hey, I'm good, right? You can move on, and then I go and execute. I continue executing this, right?
And I guess you can check for kind of self-references or circular references and stuff.
Yeah. So you basically have a hierarchical DAG system that sits under the hood here that does this, right?
Okay.
So other people, Steven, you are quiet.
No, still trying to figure out what what it actually does.
Okay. Is the example giving you some clue or not?
Yes, I said it previously, I will try to I think there are some quite similar concepts in Silva about also the capability to define some specific capabilities on clusters. And they also introduce a concept of unit. It's not very well defined at that time, so I try to exchange with my colleagues. But I will try to give you some feedbacks on what they are doing also on the topic.
See, what I did from a syntax, from a syntax point of view, I basically reused Terraform almost 95%. And the reason I did that is, but it's Terraform that can only act with KRM. So the reason I did that is because the amount of people that know and understand this is huge, right? So that helps to probably get people ahead around this. So because at the end of the day, what you see here, if you look at the syntax, right? So it's always the same. So this is basically a KRM resource, right? This is the schema. So and then you have very different, let's say, things that so you have input, you have output, you have a resource, you have a module, but these are the same as Terraform. So data is a way to fetch, for example, a resource. So for example, here, I want to get a specific entity. So the syntax that I'm using here is exactly Terraform, right? So the only difference is it's modeled in YAML, whereas in Terraform you typically model in JSON or in ACL, right? So, but this is actually, if you would put a Terraform file and map it into YAML, you will get exactly the same.
Yeah. Okay.
But then, and the difference is also it's only KRM. There is not, so this system is built only to consume KRM.
I guess the only worry I might have, Wim, is that we'd end up with this expression language being overused or almost abused, sort of like hell, like that's horrible language in hell.
Yeah, so this is the expression syntax is basically the same as Terraform, right? So the engine underneath is not what Terraform uses, because I use a more optimized technology that is available these days, right? Yeah. But the syntax to express, so for example, for each, right, is an expression. If you go to Terraform, right, and you basically Google Terraform for each, right, you will see for each with examples, right? So you have, so I'm just reusing what they
Okay.
So there's 100% Terraform syntax. So you see, if you go to the Terraform,
I know it's just an observation, because I mean we have to the business logic has to be somewhere.
That's why for me I base myself on Terraform, because I know this is one of the most popular tools today to do this. But here we actually run it in an engine, so the state is actually inside of the system. So in Terraform you have a Terraform file, a state file, and stuff like that. All that is disappeared, right? Because we actually run in Kubernetes as an engine, so the state is actually there, but the syntax is the same. You see here you have a module and you have a resource, right? So I have exactly the same.
Okay.
So I didn't want to identify a new DSL. I just says it exists, so let's reuse it, right?
Okay.
But yeah, so this thing is basically Terraform syntax.
Yeah.
So you see resource, right? You see module references, right? So all of these things are, so for example here, these are all things that Terraform defines, right? The Terraform module. Here.
Yeah.
Module box.
Fine.
It's 100% the same. There's a few small differences, but so what are the differences with the syntax right now is that I segmented this in attributes and input. So for example, here you see, so in Terraform, this is one flat list, right? So you cannot distinguish this from that and stuff like that. So, but we can discuss that, but I decided to separate that because I think it's easier. But these are all things we can discuss in my view. What's more important is the system underneath. But for me, the modeling or using let's say a DSL that already exists and is known is not unimportant, I think.
Mm-hmm.
Right, because the things that you have available in the DSL at the end of the day is variable substitution. So here basically you call upon input interface, right? So it's basically same as JSON. So input is this, right? What was it referencing? Input, wait, what was input interface, right? So we basically call upon input interface. Wait, where is it? Is that a mistake? Yeah, it might be that I'm I don't know, I was wrong. So input interface. So this will be input interface, you see here. So it calls upon this thing, right? And then executes it. So it's basically referencing variables at the end of the day. And then count index, because you have multiple. So here you do a count, you loop over the interfaces, and you index the one that you reference. So that's kind of what you do. Basically, indexing and referencing files from variables, basically.
Yeah. So how mature is this?
So this thing works. So the syntax is available. So I'm going to document the syntax because actually it's Terraformish. What the DAG, let's say, mapping is all there, right? What we have to do is map it to, so there is probably some execution engine and stuff like that. So my goal is by the beginning of next year is to do a more elaborate proof of concept with this. If that makes sense.
Okay.
But we first have to agree on the concept, in my view, but we can also go to a proof of concept and show it to get people familiar with it a bit more, right? Because I feel that it's too abstract still.
Yeah, it's just, I suppose it does have an effect on the existing project because, if people see this coming, they have a different attitude to the current code base to if they were going to have to live with the current code base for a long time. So I suppose we probably should have some sort of, it sounds boring, some sort of roadmap for when we might bring this in. That's what I'm getting at, I guess. So I mean, how much fixing do we do on the existing one?
See, this is part of so if you look to the discussion that we had with John on Porch and stuff like that. So what we discussed with Porch, this could replace or be the unit to replace the pipeline of Porch, by the way.
Yeah.
So that's what we have been discussing, is that this would be the technology that we use to replace the Porch pipeline.
Yeah. Yeah,
because it does all of that right now. So if you look, what I just showed you is actually the Porch pipeline. So I can basically execute that.
Yeah.
And then you would basically run nf deploy. You get with this technology out of the box without having to write any specialization functions. I mean, you can argue this is still code, right? I agree, this is still code, but I don't have to write Go code.
Yeah, but I guess we probably do need to think a little bit about our code base, and if people are beginning to use it now, and so if we are going to go with this, it'd be good to know. First of all, what sort of time frame you're thinking of for, say, is it R3 or 4?
This would be R4 in my view. So this would be, because this needs to be hardened, right? Hardened, tested. So I think this will not be in. We can do a proof of concept in R3, but we.
Oh yeah, of course, yeah.
Yeah. But for me, it would only go into the mainstream in R4 in my view. We probably cannot do it in R3. Yeah.
Okay.
And then second, for example, there has some byproducts. Like one of the things, I don't know, Stephen, when we were deploying, or Stephen, I don't know, he's still there. Let's say deploying packages, right? For like our SDK. So with this system, you can actually generate packages.
And there are different types of packages now. You have different hierarchical structures of packages.
So, but what I'm trying to do is what I'm talking about as a package, right? So when we build, for example, Metal LB as an example, what did we do is we fetch it from Git, right? And then we put it here. So I didn't do it yet, but I will build a Git provider, right? So you could basically say, I built a module that actually is generating the provider to be relevant in the syntax that we want, right? So that can just be fetching some KRM resources and stuff like that, fetching CRDs from place A, fetching this from place B, and so on. So we could do things like that also with this.
Thanks, Wim.
We need to. We are over time.
Yeah, I need to do the school run now. So.
Sure. Yeah.
Okay.
All right.
Thanks very much.
All right. Talk to you later. Cheers.